Welcome to this tutorial on generic constraints and upper bounds in Kotlin. In this video, you'll learn how to restrict generic type parameters using the where clause. This powerful feature allows you to write more type-safe and predictable code by limiting what types can be used with your generic functions and classes. Let's start by understanding why we need generic constraints. Here's a function called printLength that accepts a generic type t inside the function. We try to access the length property of the item. However, this code won't compile. The compiler throws an error because t could be any type, and there's no guarantee that every type has a length property. For example, if someone passes an integer or a boolean, those types don't have a length property, making this code unsafe. To solve this problem, Kotlin provides upper bounds. The syntax is simple. You write t:\UpperBound inside the angle brackets. This tells the compiler that t must be either the upper bound type itself or a subtype of upper bound. By specifying an upper bound, you restrict which types can be used, ensuring that only types with the required properties and methods are allowed. Here's a practical example. We define a function called double with a generic type parameter t that has an upper bound of number. This means t can only be a type that extends number, such as int, double, float, or long. Inside the function, we can safely call to double on the value because all number subtypes have this method. When we call double with 5 or 3.14, it works perfectly because int and double are both subtypes of number. However, if we try to pass a string, the compiler rejects it with an error because string is not a number. You can also use upper bounds with multiple type parameters. In this example, we have two generic types. K and vk has an upper bound of comparable of k, meaning the key type must be comparable with itself for sorting. V has an upper bound of any, which means it must be non-nullable. This function creates a map where keys can be sorted and values are guaranteed to be non-null. This demonstrates how upper bounds work independently for each type parameter. When you need to apply multiple constraints to the same type parameter, you can use the where clause. This is an alternative syntax that makes complex constraints more readable. Here, t must satisfy two conditions. It must be a char sequence, so it has string-like properties such as length, and it must also be comparable with itself. Inside the function body, you can safely use both the length property from char sequence and the comparator method from comparable. The where clause is especially useful when dealing with multiple constraints that would be difficult to express in the angle bracket syntax. Upper bounds aren't just for functions, they work with classes too. Here we define a container class with a generic type t that must be comparable with itself. The class stores an item of type t and provides a method called isGreaterThan that compares the stored item with another item. Because t is constrained to comparable of t, we can safely use the greater than operator for comparison. When we create a container with the number 10, the compiler knows that integers are comparable, so the isGreaterThan method works perfectly. This pattern is commonly used in data structures that need to sort or compare their elements. Let's recap the key points. First, upper bounds restrict type parameters using the t:\type syntax, ensuring only compatible types can be used. Second, when you need multiple constraints on the same type parameter, use the where clause for better readability. Third, upper bounds enable type-safe access to the bound type's properties and methods, eliminating the need for unsafe type casting. Finally, all these constraints are checked at compile time, catching type errors early instead of discovering them at runtime. Mastering upper bounds is essential for writing robust, reusable generic code in Kotlin.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.